So this problem says a merry-go-round has a radius of 2 meters and a moment of inertia of 300 kg per kg meter square. A boy of mass 50 kg runs tangent to the rim at a speed of 4 meters per second and jumps on. If the merry-go-round is initially at rest, what is the angular velocity after the boy jumps on? So here's the boy is running at 4 meters per second. Okay, so this is like a collision. Okay, it's a rotational collision, and just like in linear collision, momentum was conserved. In this guy, rotational angular momentum is conserved. Okay, so initial angular momentum, which is just the angular momentum of this guy, which is 0, plus the angular momentum of this guy, should equal the final angular momentum, and the final angular momentum is this thing is rotating with the boy on the end. If the merry runs tangent to the rim at speed and jumps on. I mean, they don't tell you where he lands, but we have to assume that he's at the edge. Okay. All right. So L initial is 0 for the merry-go-round and MVR for the kid. So 0 plus 50 kgs and R is 2 meters. V is 4 meters per second. Okay, so 200, 400 kg meter square per second. Okay. And okay, now the final moment of inertia is the moment of inertia of the disk or merry-go-round plus mr square. Well, that is given to us, kg meter square, and plus 50 kg, that's his mass, and we are assuming he's on the edge of the merry-go-round. Okay. So that's 200, so 500 kg meter square. So that's the moment of inertia of the guy, the moment of inertia of the combined system, of this system, and again everything is rotating about that axis. And L final is I final minus times omega final. Okay, and that of course should equal L initial. Okay. So from here, omega final okay. So again, this is a rotational collision, and angular momentum is conserved. Okay, we will try and do an experiment where we haven't done an experiment like this, the rotational collision. It's we'll see if we can get a successful experiment. Remember, radians is a free label, so it's radians per second. And this, well, what would be, well, okay, so that's the final angular velocity. Okay. So initially it was at rest, and it's starting to rotate at 0.8 radians per second. 0.8 radians is 50 degrees per second, roughly. Okay. 45 degrees per second, a quarter of a rotation.